Alex, who's my favorite student? Good old Anne. Hello. That's a little weird. Let's try that again. And Sirki. You can use the answers more than once. All right. Key idea, if they give me a graph, Jordan, I've got to identify what kind of a graph it is before I do anything else. There's only going to be primarily 3 this year. Position or distance versus time, velocity or speed versus time, and acceleration versus time. And I'll be honest, you're not going to see an acceleration graph all that often. You may be asked to sketch an acceleration graph. So here we have position versus time. How is he moving in part 1? Part 1 kind of got chopped off, but I hope you cleverly figured out that that was part 1. It looks like his position is increasing. I think we would say 8 to the right, constant speed. Yes? How is he moving in part 2? Yes? Part 3? And part 4, I think it's AEBE, yeah? Why? On a position time graph, where does the velocity or the speed appear? Word begins with the letter S. Slope. Positive constant slope, moving forward or to the right. Horizontal line, you're stopped, doesn't matter how high you are. Negative slope means moving to the left or backwards. Horizontal line means you're stopped. Now we're looking at a velocity time graph, a little trickier. It says, also using A to E, how is she moving in part 2? Now in a velocity time graph, velocity is not slope. Where does velocity appear on a velocity time graph? It's your height. It's how high you are. So it looks like in this section right here, we have same height the whole way through. Replace the word height with velocity. Same velocity the whole way through. Positive velocity because we're above 0. You know what? I think we're also moving to the right in a positive direction. I think that. How is she moving in part 4? I think standing still because the velocity is 0 high because height is the velocity. Number 7 says, for this question, draw the position time and velocity time graphs for the following description. All right. A student walks at a constant velocity down the hall away from her locker. Then she suddenly stops because she notices that she forgot her physics book. After a short pause, she runs back. Sorry, let's underline some. Let's try that again, Mr. Dueck. So backwards is going to be important. Constant velocity is going to be important. Stops is going to be important. Short pause. She runs backward. And she stops at her locker. Where did she start? By her locker. Where did she end? By her locker. What's my displacement going to be? 0. Okay, I better end up at 0. You know what? I'm going to start here and end here, something like that. But let's go a little more specific here. Start. A student walks down at a constant velocity. I would look for a line, not a horizontal line. I would look for a line going upwards, but a straight line, not a curve. Okay? If you see that, you'll be okay. I'll break down the marks in just a second. She suddenly stops. There should be a horizontal chunk. After a short pause, she what? Runs. Oh, faster than before. I would look for this line to be steeper and negative than your first line. And stops at her locker. Something like that. I'll show you how the marks breakdown goes in just a second. Let's do the velocity graph. She walks at a constant velocity. She stops. I'm not sure how to connect it. If you did that, I won't freak out, but I'm just going to say I know that she stops for a little while. How would I show that she runs backwards? Down. How would I show that she runs instead of walks? Further below than your first one was above. Further below than your first one was above. Now let's see, I have 1, 2, 3, 4, 5, 6. I guess each one of these is going to be out of 2. It's going to be out of 2. So in this first one, I drew 1, 2, 3, 4 little lines. Half mark off for each one you're missing, or a half mark for each line. In this second one, I drew 1, 2, 3 lines. I guess a half mark off for each line that you're missing. Did I get the second one right? Constant velocity, suddenly stops. There's my short pause. Runs back. Sure, I would take that. And again, if you connected them, I wouldn't freak out. We haven't talked about how they get connected yet, to be quite honest. Is that okay? So can you give yourself a score out of, count them, 10? And if you were away, please put a big omit where it says score so that I don't give you a 0, a goose egg. The rest of you mark them honestly. Lesson 5, the constant acceleration equations, the big 4. We're going to start to get, at first, it's going to seem complicated. I want you to trust me. I'm going to be showing you a method that at first is going to seem difficult for many of you, but I'll say it this way. I've taught far dumber kids than any of you here how to pull this one off, how to accomplish this. So don't get discouraged. At first, it's going to be sounding like 2 + 2 = a bushel of potatoes. You're going to be going, I don't say what? For many of you. What I don't want you to do, Brandon, is just turn your brain off and say, I'm going to do it my way and ignore it. It's well worth mastering the formula manipulation skill I'm going to be emphasizing over the next couple of weeks. The constant acceleration equations, and I wrote down here a specific example. We have a graph. What are we measuring on the y-axis, Zach? What's on the y-axis of this graph? Go look. What variable is sitting there? Thank you. Huh? What variable? What letter? Help me out. I'm really you're overcomplicating it. And that means we're measuring speed or velocity. This one says speed in meters per second. What's on the x-axis? T. The slope of this would be, what's the slope of a speed or velocity versus time graph? Acceleration. Okay. Here's our specific example. Above is a graph showing the uniform acceleration of an object as it was allowed to drop off of a cliff. The reason, by the way, I called it speed, eventually we're going to say if you're heading down, we're almost always going to call that negative. I just didn't want to do a big negative, scary-looking graph. So I wanted to give you, your course going to close the door behind you because you have good manners. I want to do a positive graph. So read along with me. What's the acceleration of the object? Well, the acceleration of the object, and for those of you who were away last day, this is a good review. We said that for a velocity time graph, the acceleration is going to be the slope. The slope. What is the slope here? Well, let's see. I'm going to do that right here. I'm going to say slope is the rise over the run. Ready, Dennis? The rise. How high are we right here, Dennis? 10. Oh, not that one. And so that's the top point. The bottom point is this high. How high are we right here? 2. So what's the rise? If the highest I get is 10 and I start out at 2, what's my rise? 8. Yes? Okay. Y'all see where the 8 came from? Over the run. Jake, G, my friend, how far over have I gone with this point? Can you read, kiddo? 0.8. And where did I start at what time value? 0. Okay, if I started at 0 and I went over to 0.8, I think the run is just 0.8 8. Yeah? Yeah. Nice. Nice. I cooked these numbers a tiny bit. They're close to accurate, but not quite. Hey, what is 8 divided by 0.8? Okay. The acceleration is, in real life, when you drop something, the acceleration is 9.8. But 10 is close enough, and I wanted you to get non-scary numbers. Units, meters per second per sec. Oh, no, we don't usually write meters per second per second. What are our units for acceleration? Okay. So down here where it says, what is the acceleration? 10 meters per second squared. In fact, how fast would it be traveling after 1 second if the acceleration is 10 meters per second squared? Well, if I'd started at a speed of 0, then the answer would be 10 meters per second. Did we start at a speed of 0? What's our initial velocity, Mark? Can you read from the graph? 2. You know what? After 1 second, I think I'm going to be going 12 meters per second. What we're going to try to do now is formalize that into an equation so that I don't have to kind of guess at it. In fact, it says write an equation for this graph. Mark, is this graph a straight line? Say yes. So that means it's going to be based on y equals mx plus b. Yes? Except, I'll go back to Zach. What letter are we using on the y-axis? We're not using letter y. What letter did we put there, Zach, my friend? V equals 10 is the slope. Yes? And I'm not going to use an x. What letter did we put on the x-axis instead of the letter x, Zach, my friend? T plus, what's the y-intercept? 2. There's our equation. What I want to do is I want to generalize this. So underneath here, I'm going to say, can I spot the general pattern? And I think I can. I think, Mark, you suggested that this 2 was actually that. What does VI stand for? What else will we use sometimes instead of a letter I, oh British girl, my friend? A V0, a V0, and I can't remember on your yellow formula sheet whether I use zeros or I's. I flip-flop, okay? What did you tell, what was that 10? I know it's a 10, but what did we say that was? Your hint is the word in part A. Before the physics word in part A. And I think if that 2 was V initial, I think this is V final. This is big equation number 1, almost. Almost. Not quite, almost. Did I go 2 to a page? Yeah. Okay. By the definition of constant acceleration, acceleration is the velocity change per second, blah, blah, blah. You know what? Here's the equation you can get from this graph. This is the one we're going to be flogging to death quite a bit. V final, and let's even put a vector, this works for both velocity and for speed, is equal to V initial plus A t. Oh, look up, all of you, for 1 second. Don't write this down, but look up. Technically, it's delta change in, but I've told you. We get tired. It's time. That's why there is a delta down here. T equals delta, T equals elapsed time. This is big equation number 1. VF equals VI plus AT. You've seen this before without realizing that you've seen this before. Really? Yeah. In Science 10, you were told this. Don't write this down, but just watch. I'll come back to that. Weren't you told that? Remember that? You were given it on your provincial exam formulas. And what was the change in velocity? What was change in anything? Who remembers? Jacob, what? Yes? Except before I write that, I'm going to get the change in V by itself. What's the letter T doing to that V mathematically? Adding, subtracting, multiplying, or dividing? How would I move that T over to the other side then? That equation is the same as that equation. What did you tell me change in V was? Is the same as this equation. If I wanted to get the V final by itself, I'd have to move this V initial over. What's in front of the V initial, Jacob, my friend? How would I move it over? You didn't know you were given that equation, but you were. They just wrote it differently. This is the way we traditionally write it in physics, the one that I wrote right here. But can you see it actually, Chris, is the same one that you did for you way back in Science 10 back in the day. We're kind of brushing off the cobwebs, but for most of you last year. Okay. Also, what Jacob and I just did together is what's called formula manipulation. This equation actually contains 4 different equations. You know how I know it contains 4 different equations? How many different variables are there in there? 4. You can rewrite that to get any variable by itself. Mark, if you wish to, you can memorize all 4 different equations. Don't. What I'm going to push you towards, what I'm going to teach you over the next couple of weeks is how to glance at that and in your head rewrite it into any form that you want. This is why I said for some of you it's going to sound a little bit like 2 + 2 = a bushel of potatoes, but trust me, if you commit to it, we will get all there. What Jacob and I just did was formula manipulation. You did it a little bit in Math 10 when you rewrote equations into slope-intercept form from slope-point form. You kind of moved stuff around. We're going to get good at it. But here is our first equation. This is the equation that lets you calculate how fast you're going after you know you've accelerated for a certain amount of time. This is a much more interesting equation than some of the stuff you do in Science 10. Equation number 1. We'd now also like to come up with a distance equation of some type, but we'd like this distance equation to be able to handle accelerating, because it's way more interesting when you allow that. So we're going to start off like this. You got this one, I believe, last year in Science 10. You were told that average velocity equals displacement divided by time. I want to get the displacement by itself. I'll keep picking on Jacob because you're on a roll. I want to get the d by itself. What's the t doing mathematically? Adding, subtracting, multiplying, or dividing? How would I move that t over then? Can you give me a new equation in your head with the d by itself then? What would the d equal? I got to be fussy. Average velocity times time. Average velocity times time. Okay? Actually, we're never going to use that equation. We're going to modify it one more time. We're going to make a little note here that I know how to find the average of something. Let's suppose that Chris has $10. I've got $20. What do we average between us? I heard someone say it. What? 15. How the heck can you use his 10 and my 20 and get an answer of 15?
Add it and then divide it by 2.
Add them up and divide by 2. Brad, I didn't have you for math last year. I had you for science. Okay, can't pick on you. Brandon, I had you for math last year. I'm going to see if I can jog your memory. I'm pretty sure we did this in the systems unit. Are you ready? Are you ready? Are you ready? Brandon, what's the average the same as? Read that to me. When I see the average, what can I write instead? Wherever I see an average, what can I replace it with? Are you saying that I can replace this V average with that? we're doing, you may recall, in systems of equations last year, we're doing some substitution. Remember, I think you remember that little dance that I used to always do with kids, right? So this is equation number 2. Displacement is that's equation number 2. Could you get your yellow formula sheet out, please? As long as there's one per table, as long as you can see one. So if the person next to you has it out, that's fine. Look at the front of it. You want to find where I've given you these equations. So as long as one of you has a yellow formula sheet, I'll pause for a second while you go hunting. Can you put that between the two of you? You can share temporarily. Oh, Oliver found his, okay. Dennis, you have yours? Get it out, get it out, get it out. Can you find this on there somewhere? Yes? Should be near the top, I hope. Yeah. Found it? Yeah. Can you see, and the reason I'm doing this is I think this one we typed differently. Do you see this one on your formula sheet? Except I think, because Mr. Kamosi typed this up, how did he write his? I don't think he went this plus this divided by 2. I think he said dividing by 2 is the same as multiplying by. Is yours with the 1/2 in the front? Okay, but it is the same equation, I'm telling you, okay? Hey, keep that out. You might get a preview of where we're going if you want. So this is big equation number 2. Example 1 says, oh yeah, turn the page. An object starts at rest and at position 0.0 meters. It accelerates at 2 meters per second squared to the right, positive 2 meters per second squared. It says, fill in the chart below to find its velocity and its position at. What we're going to do is we're going to see if our equation also gives us the same thing. Let's see. So we have time 0, 1, 2, and 3. Okay, at time 0, according to this question, how fast are we traveling?
0.
How do you know? At rest. Okay? What's its acceleration? How many meters per second squared? So after 1 second, how fast is it traveling? After 2 seconds, how fast is it traveling? After 3 seconds, how fast is it traveling? I think we can fill in that column okay. What does it want in the next column? The time interval. So the first time interval is from 0 to 1 second. The second time interval is from 0 to 2 seconds. And the third time interval is from 0 to 3 seconds. Okay. What do they want in the fourth column? No, I didn't say velocity. I put a word in front of there. It's important. I think average is going to be initial plus final divided by 2. Yeah. Okay. So what's going to go right here? Well, what's my initial velocity at time 0? What's my final velocity at time 1? Divided by 2. In your head, what is 0 plus 2 divided by 2? What's my average velocity? How far did I travel in that time? Well, displacement is that? What's my average velocity in this row right here? How much time has elapsed? How far have I traveled in the first second? In your head, Jacob, what is 1 times 1? We're starting off with nice numbers. You may be accelerating at 2 meters per second squared, but in that first second, you only managed to cover 1 meter. How far do you cover in the first 2 seconds? Well, let's get the average velocity. My initial velocity, still 0, still started at rest, yes? But how fast were we going after 2 seconds?
4.
Hey, in your head, what is 0 plus 4 divided by 2?
2.
So I think my average velocity is 2. How much time has elapsed in this column from 0 to 2 seconds? If you were to take a picture after 2 seconds, and if we were running along a number line, how far have we traveled? You're right.
2.
No.
4.
Brad. By the way, Brad, how far have we traveled after 1 second?
1.
How far have we traveled in 2 seconds?
4.
How far did we travel in that second? And I know that sounds weird. How far did we travel in second number 2?
3 meters.
Must have been 3 minutes. Must have been 3 meters. Right? If I'm at 4 and I only got 1 done in the first second, I'm picking up speed, Jordan. Yes, 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 yes. Let's keep going. This is kind of nerdly fun. I average here would be 0 plus 6 divided by 2. Jordan, in your head, what is 0 plus 6 divided by 2? Oh, if it was only always this easy, right? 3. So, Jordan, my average velocity was 3, and that happened over 3 seconds. After 3 seconds, how far have we traveled? 9, or are you, Dennis, saying no? 9? Okay. Could be Dennis saying no. 9? Not yet, not yet. Mr. Okay, fine. Oh, and Jordan, while we're at it, can you see how far did we travel during second number 3? How many meters must we have covered, folks? Do you see it?
5.
Must have been 5, right? Because we were at 4, now we're at 9, must have been 5. Okay. We're picking up speed. This is the long way. But what I'm trying to do is convince you, Olivia, that these equations do work. We're not going to do a chart from now on. We're going to tend to move away from that. I was gonna have you graph this. Meh. I'm going to jump. So go too much. Whoop. Too much work. Too much work. I want to get to the distance equation. Now, what we are going to assume for the rest of Physics 11 and for almost all of Physics 12, Jacob, my friend, is, can you read to me what it says here, Jacob? This assumes what?
Uniform.
Which means what?
Unchanging acceleration.
Unchanging acceleration. We can have changing speed. I can deal with that, no problem. No problem. By the end of this month, you'll be able to do it in your sleep. Changing distance, no problem. Changing acceleration, that's really where you need calculus. So we're going to stay with a constant acceleration for most of your high school career. Having said that, that still opens up some very cool problems like free fall and things like that. So if we have uniform acceleration, we can find average speed, written V average, by, we said that was final plus initial divided by 2, or it could be initial plus final divided by 2. It's really add them up and divide by 2. I think that's on your yellow formula sheet somewhere, yes? I think?
Yeah.
Let me see. Got to be there somewhere. I would have put it there somewhere. Oh yeah, there you go. Oh, Mr. Kamosi, instead of dividing by 2, he put the fraction in front, 1/2, because multiplying by 1/2. See it there? Is the same as dividing by 2. And it's on the right-hand side? Yeah, yeah, yeah? Okay. This one is, I like this better because it's easier to type into my calculator, but whatever. Oh, by the way, if you're accelerating uniformly, the average velocity actually occurs exactly halfway between the minimum and maximum velocities when you're talking about time. Yeah, big deal. Distance. Two more equations you're going to get today. Okay? And that's going to be pretty much it for the next 3 weeks or so. But we're going to apply them in all sorts of different ways. Distance is defined as average speed times time. But Brandon, what did we say the average was? So when I see a V average, what can I write? So whenever I see a V average, I can replace it with? That's what I did right here. See it? I wrote the, by the way, that's V average. Horizontal line is also a symbol for average, but I couldn't fit the average in there. I replaced V average times time. So far, so good. Oh, Chris, could you read me this here? And could you read me that?
Since velocity.
VF, just say VF.
Okay, VF equals VI at AT.
Plus AT. Read it again. For a reason, I'm not making fun of you.
VF equals VI plus AT.
Wherever I see a VF, what can I write instead?
That. VI plus AT.
When I see a VF, what can I replace it with?
VI plus AT.
Seeing a VF is the same as?
VI plus AT.
Is there a VF right there?
Yes.
What can I replace it with?
VI plus AT.
I'm showing you how we derive this equation. I will not ask you, Cole, to recreate this derivation, but I'm a nerd. I can't resist showing you where it comes from, okay? So don't freak out. I'm not going to, on a test, say, please, for marks, generate the distance equation. But Kylie, I will almost never give you something without saying, here's why it's true and where it comes from. You okay with this, Olivia? This VI right here just dropped down. That's why there's a plus VI on the end. And I replaced, according to Chris's instructions, this V final with a VI plus AT. Olivia, my angel, can you read to me what it says in the bracket?
V, is it F?
I.
VI plus AT plus VI.
Say it again.
VI plus AT plus VI.
Did she say VI twice? Hey, that's like terms. Instead of writing VI plus VI, isn't there a shorter way that I can write that? What's X plus X? 2X. What's Y plus Y? 2Y. What's VI plus VI? Cool. So I think what you're saying, Olivia, is this. I can write this as 2 VI plus AT all over 2 times t. Again, Jacob, am I going to ask you to redo this on a test? No, but I think this is a good mind exercise for you. You follow me so far? Do you see brackets, Jacob? Say yes. See brackets? You know what? I'm going to multiply that t onto there and onto there. It's what Mr. Rocca or your teacher might have called front door bomber, except it's on the end, so it's back something, whatever, we're distributing. We're going to go like this. Okay? And we're going to get two VIT plus a, I guess it's t times t. What's t times t? That's t plus t is 2t. What's t times t? Okay. Is that whole thing divided by 2? That's the same as each term on top divided by 2. I can actually break this up into 2 VIT over 2 plus AT squared over 2. That's the same thing. Why did I do that? For that first fraction, is there a 2 on the top? Is there also a 2 on the bottom? What can you tell me about those there 2's then? I get this. D equals. That first little mini fraction, Taylor, turns into VIT. Plus, dividing by 2, what's that the same as multiplying by? D equals VIT plus a half AT squared, which is definitely on your formula sheet. Oh, except displacement, velocity, acceleration. It works, Mark, for the vectors. It also works for the scalars. So we'll add the vector notation saying, hey, it works for that. And Chris, if it does work for that, then it'll work for the scalars. You don't yet realize how hugely useful this equation is. This one is the biggie. It's a little complicated, but this handles almost anything. And there's one more. This last one is really, really awkward to derive with your skills right now. I'm just going to give it to you, but in a few months, I'll suddenly show you where it comes from. It comes out of work and energy. In fact, it pops out of the kinetic energy equation, and it goes like this. VF squared equals VI squared plus 2AD. In fact, I think the 4 equations that I just gave you should be almost all in a row together, if I'm not mistaken. There should be a D equals V on your formula sheet. I think, aren't they all in a, you need to, so where it says acceleration, second row, I think it's got all 4 of them in a row there, yes? Below the word acceleration, I think. VF equals VI plus AT, D equals a half VI plus VF over T, or D equals VI plus VF over 2 times T. D equals VIT plus a half AT squared, and VF squared equals VI squared plus 2AD. These are the big 4. The big 4. We can use these to solve almost anything now. Say what? Oh, I put them in a lovely little box right here as well. These are the 4 equations describing uniform acceleration. I cut and pasted this from a textbook, and in the textbook they didn't use I for initial. Olivia, what did they use instead of initial?
No.
Oh, interchangeable. You can use V0, VI, whichever. Okay. Same equations though, see them? How do you know how to use this? We're going to defic. Let's do an example. An object starts at rest. All of us right now, let's underline the word at rest. And it travels 12 meters over the next 3 seconds while accelerating constantly. All right. Vanessa, what does part A want me to find? Let's put a little letter A and let's write down A equals question mark. A equals question mark. Now I'm going to defic. Remember, defic stood for list your data, find a formula, insert numbers, crunch the answer. I'm going to go through listing my data. What does at rest tell me?
Start at 0.
What? I heard it over here. Zach, what? I'm now going to start, from now on, I'm going to say, let's use physics terms. In particular, we're looking for VI, VF, A, and D whenever possible. So VI is 0. Check. Keep reading. I run into a 12. What's that? I run into a 3. Come back to that for a second. B. Realize what I should have done is I should have had final speed first and then acceleration. So I think, well, let's see. We'll stick with A. Sorry, guys, that was terrible. It wants me to find acceleration. Here's what I'm going to say to you. Somewhere in those 4 equations in the box above, only one of those equations has an A, a V initial, a D, and a T, and no other variables. Find it. Which equation has those 4 variables and nothing else? You gotta find it. This is the skill you need to pick up on. So if you're hoping desperately right now that you can turn your brain off and just kind of, no. You need to be able, you need to reach the point, and we're gonna build to it, relax. But this is where I'm pushing you into the shallow end of the pool, and I'm saying start getting your feet wet. Which of those 4 equations in that box has a D, a VI, an A, a T, but no VF? Zach, read to me, please. Write it down. D equals VIT plus a half AT squared. D was list your data. F was find a formula. We have. Are any of those variables zeros? Mark, which one? I can't hear you.
Initial velocity.
You're saying that right there is 0? What's 0 times 10? What's 0 times a million? What's 0 times x? What's 0 times anything? Right? Because that's a 0, right? So even though originally my equation said D equals VIT plus a half AT squared, I can already modify this into D equals a half AT squared. You okay with that, Jake? Yeah. What are we trying to find? Okay, see it in the equation? What side is it on? Left side or right side? Right side. What else do you see there? I see a 1, a 2, and a t squared. See it? What's the 1 doing to the a mathematically? Adding, subtracting, multiplying, or dividing? It's on the top of the fraction, so it's multiplying. How would I move the 1 over then? Divide. Is it a 1 though? Will the 1 make any difference dividing or timesing by 1? I just only mentioned it, Carly, because if there had been an actual non-1 number there, I would say I'm going to divide, but we can ignore the 1. What's the 2 doing? Adding, subtracting, multiplying, or dividing? Dividing. Why do you know it's dividing? You're right. Bottom. How would I move it over? Times? So here's what I'm saying. Drop your equal sign down. The letter D drops down like a domino because we haven't moved it around at all. But you're telling me that instead of a 2 on the bottom on the right, that's the same as a 2 on the top on the left. Yes. Have we taken care of the 1? Say yes. Have we taken care of the 2? Say yes. What else is next to the a that we want to move over? What's the t squared doing to the a? Adding, subtracting, multiplying, or dividing? How can I move it over? Are you saying that? That is yet another new equation. Do not memorize it. Do not memorize it. It can be, Jake, derived from those 4. And this is tricky at first, but please trust me. Dro, I'm going to push you and push you. You will get the hang of this formula manipulation. And in fact, I'm telling you right now, the way I've just explained it to you in 3 weeks will be painfully slow. The vast majority of you will glance at that, go straight to here, and you'll do it almost without thinking. And what I'm trying to do, Oliver, is I'm trying to cut down on your memorization. If you really want to, you can memorize that new equation. It's not on your formula sheet. Jordan, don't. It's a waste of brain power. Do we have the a by itself? Well, let's plug and chug. I think a equals 2. Hey, what did we say d was? Divided by, what did we say t was? Don't forget the squared. Okay. On your calculator, what is 2 times 12 divided by 3 squared? By the way, we're going to be doing some fairly complicated stuff on our calculators. When I say try this on your calculator, if you don't, you're setting yourself up to do lousy on the test. Time and time again, I see kids that have all the right work written. They get the wrong answer. And I know that kid didn't bother, oh, he picked up on my hint. That kid didn't bother getting their calculator out and trying this for themselves, because there are going to be some weird quirks of your individual calculator that you need to figure out. Some of the quirks will be weirder than others. Oh, sorry. It's 2 times 12 divided by 9. 24 divided by 9. Same as 8 divided by 3. Is the answer 2.6666666666?
Yes.
Let's go back to the original question. Oh. Chris, my friend, how many sig figs?
2,
Nope.
3,
Why 3? Because that's why they put that 0.0 there. Yes? How many sig figs?
3.
3. 1, 2, 3. Technically, right? Because we're multiplying, dividing. Units, it's acceleration. Meters per second squared. Right? B. B. Lisa, what's B asking us to find? Final speed. Hey, what's that in terms of the variables that I've given you in those 4 equations up there? VF equals question mark. Now, we are looking for an equation. It has to have a VF in it. And then it'd be nice if it has distance or time, or, you know what? I do know the acceleration now, so I can even use one that has acceleration in it if I need to. There are several that have VF in them. Is there one that has the VF by itself already?
Yes.
Which one?
The
Oh, well, heck. By the way, technically these are all vectors. I'm not going to be fussy if you leave your vector signs off. I'm going to try and remember to be consistent because it's a good reminder, but whatever. So here, Jacob, do you notice VF's already by itself? I don't need to go through this. All right, let's plug and chug. Jacob, my friend, what did we say VI was from our list over here? Oh, that's nice. I like that. The 0 times table, the easiest one. Yeah, shut up. Okay. What's right here, Jacob? After the VI, what mathematical symbol?
Plus.
Yeah, I'm going to drop a plus sign down. I didn't know A at the beginning, but now I know A. I just figured it out. What did we say A was? Now, I'm going to write 2.67, but if you did this on your calculator, I hope you still have that 2.666666666666. Use your answer button on your calculator, because that's going to be a little more accurate. But I'm going to write 2.67. Keep going, Jake. T. I agree. Hey, humans, what's V final? 8 point. I don't think it's 8.01. If you used your answer button, I think you'll find it's exactly 8. You round it off. And I would be okay with that, but I'm going to try and teach you, try and get used to using that wonderful answer button. It's one of the many, many, many reasons I went on that rant at the beginning of the year about having a good calculator. By the way, why technically would I write that? It looks like 3 sig figs. Units? Not squared, that's acceleration, right? Let's suppose I gave this to you on a test and you're finished the test early. You're going to check your answers. Hey, is there another equation that has VF by itself? Yeah? Which one? The fourth one, yes? Although it doesn't quite have VF by itself, it has VF. How would I get rid of a squared? Okay, put your pencils down for a second, but here's how I could check my answer. Or I could go VF squared equals VI squared plus 2AD. How do I get rid of a squared? That is really that. Square root both sides. And I could go VF equals the square root of 0 squared plus 2 times 2.666. I'll carry a few extra sixes in there. What's the distance? Do we know the distance? Oh, because they gave me that? Let's see. So I could also go 0 squared plus 2 times 2.66666 times 12, and then square root of that. And do I also get 8? Do I now know I'm right? You're going to find occasionally, more than occasionally, there's more than one way to get there. Which way's right? Yes, they both are. Although I'll almost always pick the laziest, easiest, simplest way, Sabrina. Turn the page. Do you now have those 4 equations in front of you anymore? Say no. Wait a minute, are they on your yellow sheet in front of you? And one of the things I'm trying to do, Vanessa, is actually teach your eyes where to look on the formula sheet so that you don't have to go hunting all over your eyes will actually remember where to glance. Our brains are impressive. So you got the yellow formula sheet hopefully in front of you, yes? All right. Jake, can you read to me, please? Example 3.
A dolphin.
Hey, a dolphin! Flip. Okay, keep going.
A dolphin accelerates from 1.0 meters per second to 7.6 meters per second in 5.5 seconds. Find the acceleration.
Okay. Is there an A and a B?
Yeah, B.
How about let's go like this. Right? Be organized a little bit. A. What did you say they wanted me to find, Jake?
The acceleration.
A equals question mark? Can make it, my friend?
Yeah.
Okay. Now let's look for physics words and numbers. I see that 1.0. It's meters per second, so it's a velocity. Which one? Alex. I see that 7.6. How do you know it's V final? First of all, you know it's a V. Why? And again, one of the strategies I want to suggest to you, it's worth memorizing units because it really cuts down on your thinking. You know it's a velocity because it's meters per second, and the only one left is v final. I'm almost never going to ask you to find v average, by the way. That's kind of a waste as far as I'm concerned. What's that 5.5? Tell me, do I have an equation that has A, VI, VF, and T in it? I do? Brad, can you read it to me? You were right. I totally agree. By the way, I will give you, if I made this question will usually be worth 2 marks, maybe 1. I'll give you a half mark for just identifying the equation, because that's, to me, 90% of the battle. Noah, what are we trying to find? What side of the equation is the A on? Do you see other stuff there? Okay, let's deal with it. There's a T, but it's multiplying. Deal with that last. We actually do reverse bed mass for equation solving. We're going to deal with stuff that's being plussed and minused. Do you see the VI? What's the VI doing to the A? Adding, subtracting, multiplying, or dividing? Did you say adding? How will I move it over then? So I think, here's what I'm hearing from you. You're saying the VF would drop down and there would be a subtracted VI. Is that what you're saying? Okay. What else is next to the A? A time. What's the T doing to the A mathematically? Adding, subtracting, multiplying, or dividing? So how will I move it over? Are you saying I would then go divide that whole thing by T? By the way, I gave you that equation for acceleration on the woodpecker assignment. We did this a while ago, but I didn't tell you. It was actually from this one here. Chris, do I want you to memorize that equation? Say no. And again, if you're finding this formula manipulation tricky, it just means you're normal, but I'm going to nudge you into it, Taylor. It's really worth mastering. This is a new equation. Let's plug and chug. What's V final? Oh, keep going, Noah.
7.6.
Thank you, Noah. That was amazing. Minus, keep going, Noah. All over. Now, this is one of the things you need to get as a habit. Is there more than one number on the top of the fraction? You have to put that in brackets. In other words, if you type this, 7.6 minus 1 divided by 5.5, that's wrong. Your calculator has no way of knowing that 7.6 is supposed to be on top of the fraction. You have to go bracket 7.6 minus 1, close bracket, divided by 5.5. Mr. Dueck, why can't I just do the minus 1 in my head? You can, but there will be ones you can't do in your head. So I'm saying if you got 2 numbers on the top or you got 2 numbers on the bottom, you've got to start bringing brackets into the fold. You get 1.2? Units. That M didn't work out very well. Come on, M. There we go. Kylie, what does B want me to find? D equals question mark. So I'm looking for an equation. It has to have a D in it. It would be nice if the D was already by itself, but not mandatory. And I'd like it to have VI, VF, T, and, okay, A. There's 2 equations that have the D by itself. Are there not?
Yeah.
Okay. I would use the first one, the 1/2 VI plus VFT. And the reason is I'm a good test writer. Is there a chance that I got the acceleration wrong? So if I can avoid using acceleration without doing extra work, I'm a good test writer. I'll try and use what they gave me. Oh, and then maybe I can check my answer with the other one. And if I get the right answer both times, I know the acceleration's right. I think I would use, is it this one? D equals VF plus VI over 2 times t, or I think yours has a 1/2 in front, whichever variation, yeah? What's VF?
7.6.
VI 1 divided by 2 times, how will I type that into my calculator? Bracket 7.6 plus 1, close bracket, times 5.5 divided by 2. You get, I guess, to 2 sig figs, because it looks like they gave me 2 sig figs in my data. 24. And again, if you wrote 23.65 or 23.7, I'm not taking marks off. What I am saying is I'll keep re-emphasizing sig figs whenever I can. Units, meters.